chemistry, and we're specifically going to look at electroplating. So our learning intentions is to discuss electroplating and to show the movement of ions under the influence of an electric field. So to begin, let's show the movement of ions under the influence of an electric field. And to start, in order for ions to move in an electric field, they need to be dissolved in water. So they can't be in a solid form, because in a solid form, all the ions and molecules are locked into fixed positions. But when they're a liquid, they're free to move around. So we can explain electrolysis by using terms where ions move towards electrodes. So to demonstrate this, we should use ions of different colours. So we can use a green solution made up of copper sulfate and potassium chromate. And we can see here that the copper sulfate would be blue and the potassium chromate would be yellow. So that is what gives us our green colour. And these would be dissolved in ammonia solution. And 1 drop of this should be placed on a sheet of paper that is connected to a power supply. So if we start up that power supply, what we will see is that we will see a blue colour forms at the negative electrode, and this is because the copper ions are moving towards the negative electrode, and we would see a yellow colour form at the positive electrode, and this is because the chromate ions are moving towards the positive electrode, which is the anode. So this helps show the movement of ions under the influence of an electric field, because we begin with a green solution and end up with 2 separate colours of blue and yellow at opposite electrodes. So now what we're going to look at is we are going to look at electroplating. Now, electroplating is very useful in industry, specifically in jewellery making, because often objects of jewellery are made from a very cheap metal, and what happens is a more expensive metal is then plated onto that. So when we look at electroplating is a process where electrolysis is used to put a layer of one metal on top of the surface of another. So in jewellery, they will get cheaper metals and plate them with the likes of gold and silver. So this plated metal, or the layer that goes on top of the surface of the cheap metal, that layer will be very thin and it will make the cost of the item low. So another example of this would be electroplating cutlery. So as we can see by our setup here, we have silver metal in a solution of silver nitrate, and we have a nickel spoon. So similar to the electrolysis of copper sulfate using active copper electrodes, here we would have the silver ions from our silver nitrate solution plating onto our nickel spoon, or coating the nickel spoon in a thin layer of the silver metal, and then the silver metal here will lose silver ions into the silver nitrate solution to replace the ones that have been absorbed onto the nickel spoon. So let's explain this in a little bit more detail. As we can see, we've the diagram that I've just gone through, and it is necessary that the object to be plated is connected to the cathode, or the negative electrode. So here we can see that we're plating the nickel spoon, so it is connected to the cathode, which is the negative electrode. The electrolyte, which is the solvent that your electrodes are sitting in, it must be made of the salt of the metal that is being plated. So for example, here we can see that we are plating silver onto nickel, so our electrolyte must be a salt of silver, so we've chosen silver nitrate. And then the anode, which is the positive electrode, must be the same metal that is being plated out. So it must be the metal that is in your electrolyte. So as I've said already, when energy is applied and we have a voltage running through the system, the silver ions from our electrolyte will plate onto the nickel spoon. So that means that there is a loss of silver ions here in our electrolyte. So that simply means that the silver metal will lose some of its silver ions to go into the solution to replace the ones that have been lost through the electroplating of the spoon. So some applications of electroplating include silver plating of nickel cutlery, which we've already spoken about. And here we would have electroplated nickel silver, and it increases the value and the appearance of the cutlery. Another one would be coating steel with chromium, and this again, it enhances the appearance, but it also improves its resistance to corrosion. And it's important to note here that the steel is plated onto nickel first before the chromium then is plated onto the steel. Purification of copper, which we've already discussed in a previous video. And it's important to know that silver, chromium, nickel and zinc are the metals that are most commonly electroplated onto cheaper metals. So that's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.